stage is yours.
All right, thank you, and thank you for organizing all of this. So that's web security in 2022, or basically how you do web security right now. My name is Luca. As Marco said, I run a company called Doyensec. I've done a bunch of different things, all in the AppSec realm. And I actually don't want to bother you too much on my stuff. I do want to say a bit, what we do, because this presentation was born through some of the things that we do at Doyensec. So we're a product security testing company. We do consulting for tech company and fintech. And by doing that, we find a lot of bugs. And when you find a lot of bugs, you then understand trends. And so hopefully today I can share with you some of the trends and new techniques and vulnerabilities. But this is not just my work. So we have an event in the company. So we're a full remote company, 20 people. We all are very passionate. We like to share knowledge and learn from each other. And the way that we do that is by organizing this internal event called Best Bug. It used to be once a month. Now, because we are much bigger, it's a weekly event where people rotate, 2 people each Thursday. They present quickly some new vulnerabilities and techniques they discovered from the past weeks. It used to be, as I said, an internal meeting. So we had this disclaimer: what happens in Best Bug stays in Best Bug. But then over time, I realized that actually what I see that my people are doing is what it is web security today. And so this presentation is both a combination of interesting technical vulnerabilities, but also hopefully like an insight into the trends in web security. So a few disclaimers. It's mostly web-centric. We work mainly with web tech, which doesn't mean only web application. I mean, web is basically everywhere, from desktop apps to mobile and other stuff. But of course, the technology are web. So we talk HTTP. Because of the industry we work with, it's mainly focused on tech and fintech, which also kind of forces us to work on what I would consider modern frameworks. So you're not gonna see bugs on PHP and Java. Instead, a lot of JavaScript, TypeScript, and Go. Not all these bugs, not all bugs are mine. So I will give credits as credits due. Also, while we find, probably several hundreds bugs every year, it's really just a small percentage. They say there are 10,000 CV every year, probably 4, 5, 10 times more bugs. So clearly, you should, not consider it as a statistically valid sample. But who cares? Now that there was .10 is. And then because of the 40 minutes time slot, I decided to drop completely techniques that are definitely very modern and definitely widespread and also very interesting, such as server-side request forgery, HTTP request smuggling, and basically all the stuff that James from Postwigger discovers every year. So instead, we're going to focus on other stuff. There's a lot of demo. As I get older, I'm getting more brave. So today we'll do all live demos. Let's see how it goes. Hopefully, demo gods. And we start with what I think is right now my favorite bug class. It's around vulnerability in state machine. So what is a state machine? It's basically a computational abstraction. It's a way to describe how a system works, for example. So look at the diagram at the bottom. There is a state one. You apply an input X, and you go to state 2. And similarly, from state 1, you apply Y, you go to state 3. But you see, for example, there is no transition between 2 and 3. And so, this abstraction is actually implemented and used in many, business logic components of a lot of things, from TCP/IP stacks, but also on more recent things like WebRTC. So when you do a Zoom call, a WhatsApp call, a Signal call, you're basically using WebRTC. What is interesting about WebRTC is that the data channel, so the channel where the video and audio is streamed, is disattached, disconnected from the signaling channel, which is what keeps the states of the call. So the peers, so the software that run on both peers, needs to keep track of is the call incoming? Did the person pick up the phone? And all of these things. So any bugs along the way might lead to pretty interesting bugs. And Natalie from Project Zero found an amazing bug that's the reference. It's way too complex. I would have to spend the entire presentation on that. But if you love state machine bugs, that's your bug advisory to read. Instead, we're going to do something a bit more, digestible for today. So this is a bug we found in a web application. So you go to an authenticated page, typical login form. You give your credentials. You go to an authenticated without 2FA state, where the application will present a web form where you introduce your 2FA OTP. And then if that is successful, you go to an authenticated state. And this was actually implemented as a state machine. And so the question from a security researcher standpoint is, can I go from authenticated to fully authenticated, for example, using a transition that does not involve credential or the 2FA OTP? So let's go into code. Code is truth. So don't worry, I'm going to guide you. So if you don't understand a lot, it's not important. What important is, so first line, await login, is basically logging in the user. You pass the email and password. Assuming that's successful, down below where you see if account two-factor secret, basically if the user has two-factor enabled, you will then display, the application will then display the TOTP prompt. And then in the same file down below, there is a statement where if two-factor token, so if, and this comes from a post request, so it's user supplied, if there is a two-factor token passed, get the user by email, verify the two-factor, and if successful, then you're authenticated. And you might have already spotted the bug, or might have guessed. And the problem here is that you can get into this state by just passing a post request with a two-factor token. So basically, we are from authenticated state to full authenticated, where the transition, the question mark, is actually the 2FA OTP. Of course, has to be the 2FA OTP of the user. But bugs are always together. So there was no rate limiting, so you could basically brute force a 6-digit PIN and then log in. And if you think about it, it's actually an irony of security, because this bug, which is an authentication bypass, only affects 2FA-enabled accounts. And personally, for me, was kind of the irony of life. I've done the linguaggi formali, which is formal, grammar language class at the Politecnico Milan, maybe 8 times. I was ready to drop because of this exam, and it's actually the only exam I'm using 20 years later. And this book is actually on my desk right now, as you see in the picture. So you should study and enjoy the stuff that you hate the most. The second one is my favorite quote, also Project Zero guy. And the concept is, when you're against a very hard target, just think that if there are enough bugs, it doesn't matter how it's designed. All the design constraints can be broke by just having enough sufficient bugs, basically. We start with a demo of the exploit first. So, because we all like calcs. So this is an RC in VS Code. Hopefully it works. It's loading, and then at some point you should see a calc. What is these things about? So this bug starts from typical cross-scripting. In 2021, Justin Steven, great researcher, you should see this GitHub repo, has a lot of nice advisory, found this cross-scripting in this file format. The interesting thing about this file format in VS Code, it's whitelisted, so you don't have the click-to-play prompt in VS Code, which is very interesting from an attacker standpoint. But it's vanilla cross-scripting, right? You see here. He, in this blog post, described some of the techniques he tried but didn't achieve RC. So we took it as a challenge, and that's basically the ride to get there. To do that, I need to introduce a bit of Electron stuff. Don't worry if you don't know much about Electron. Just think Electron is a framework that allows you to build web desktop apps with web technologies. And almost any Electron.js exploit works in 3 stages. So you first need to take control of the DOM. That's what we got with the cross-scripting. You then have to bypass isolation in order to basically do more privileged operation, like, for example, accessing Node.js APIs. And of course, once you have access to Node.js API, you basically can write Node.js code, which means it's game over. How we do that? Well, let's look at the design. And this is a pretty complex and well-designed application. So you have an external renderer, which is called browser window. That's the terminology in Electron, and has node integration on, which means that you can access node primitives if you have content inside that. These containers, so think about it as a containers, web containers, has an origin VS Code file, which is equivalent to the file handler. However, there is some check in the code to make sure that the file cannot be outside the program folder, so the folder where Visual Studio is installed. In order to open untrusted content, such as the files that we just dropped, it actually uses a combination of iframes. They are in this low privilege mode called VS Code Web View, and there is no node integration. All of this is implemented through iframe with Sandbox. So what is Sandbox? Sandbox is basically a way to isolate content. You use that when you want to load untrusted content in your page. And you can set some attributes. And one of the interesting attributes that was set here is actually the allow same origin attributes, which basically makes the communication possible if the two containers run in the same origin. So the idea here is that if we have code in where the XSS things is, and we can have that container in the same origin as the VS Code file, then we can access the node integration primitives by using something like top.require. If that's confusing, let's see in practice. I'm just going to kill because it's always better to start fresh. So this is just the injection. And you see here is just an image which is loaded with the image we're loading. So you can already see here that we have 3 levels. So that's actually the VS Code, and then the three other ones. Let's see if we can quickly pick the iframe. So you see here the injection. If I go down above here, sorry, up here, you should see here the iframe, and you should see here the allow same origin. Hopefully it's clear enough. So let me show you in practice, the things I tried to explain before. So, so here we are inside window location.href. We are inside the web view. If from here we try to do something like let's say require, we get an error. The iframe, with a specific origin, so in this case, the VS Code web view is blocked from accessing the top ones. Now, if we look at the top one, and we do the web location, you see the VS Code one, okay? So to simulate and try what I basically told you before is, let's go back to the active frame, so that's where the injection is. We do window.location. You see that a refresh occurred, the image disappeared because we just loaded a random HTML page, which is actually the main container, but it doesn't matter. And then if we redo now top require, and we go to the proper context, you now get a different error. You get an error that you cannot require a module called AA or whatever it's called here, because obviously this doesn't exist, but it actually, the require actually worked. All right, so let's go back. So at this point, it should be clear that, okay, if we have a file and it's our arbitrary content, we can, do a window location override and run that code. But how do we get our code and how do we discover where it is? Luckily, there was another bug also in VS Code, so it's kind of an interesting technique that is still, I think, applicable, where you can do path traversal to bypass the VS Code file limitation. So we now are at the stage where we can reference any file, but where is this file, right? It makes sense that the file is inside the repo, because that's the obvious attack, right? You have a malicious repo, you clone that one, you drop the file, so even the payload could be in that repository where it is. And it comes to help another technique, or rather a function like the web, which is listening to post messages events. What that means, let's see in practice. And let me actually see if we have in the history, so it's much faster for me. Yes. Okay. Yes. Let me try to. Yes, I was trying to zoom a bit, but the debugger, I think, started already. So. Okay, so hopefully you can see here. So this is basically kind of the skeleton of the final exploit. It's really not important. I'm going to go very quickly through it. I just want to show you, hopefully we didn't miss the debugger breakpoint, like the actual point, because there are a couple of other breakpoints that I said before. So the first line here is we're setting where the application is. That's the typical folder for Electron apps. We then listen for the on message. You see at the bottom, we're sending the post message to a do reload. It doesn't matter what it is. I mean, it's an internal app functionality that allow you to trigger a reload of the page. And by doing so, you are basically reloading all the content. And the interesting thing is that one of the events contains the actual content that you're rendering. And inside the HTML content, you have the base href attribute, which contains the actual file path. And so the idea is that we extract that one. You see here where we do leak location. We do the path traversal, and then we wait a bit because timing is important when you do these things, and then you override the location over here. So let's see if we run the debugger again. I think we did miss the debugger. Let's see. So let me try one more time. Oh, no, I know why. Because we're not in the right context. All right, so we see here the debugger is paused. If we now open, let's see, event.data.args.content, we see that's the HTML content. Okay, let's see. If you see the first line, base href, and you see there is /user, iki, desktop, blah, 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 that's actually the path. So we're taking that content, and that's what we use to know where the file is. You put all together, and that's basically the exploit we saw at the beginning. Third bug is also one of my favorite bugs. It's a bug and in Signal Desktop, and I'm showing you here the patch, which is very interesting because the patch is actually a change of one word, and the word is await. Why do you need to wait? Always wait when you want to verify signatures. So verify signature is a function that is used to verify software updates, and it's defined as an asynchronous function, so you need to wait for the promise to return and give you the value. If you don't do that, the execution will continue, and that's probably not what you want when you are supposed to verify the content of a file. Again, very simple miss, but obviously very interesting bug from a technical standpoint, and I'm actually pretty sure there are many bugs out there just based on this very similar pattern. This is a bug from Mohamed and Francesco that are actually somewhere here. Amazing bug because to me it's actually a great example of web and cloud combined, where you have a web application that is actually secure or properly implemented. You have a cloud infrastructure that is properly configured, so no misconfiguration. You put them together and you get a bug, and it's like, how is that possible? Well, AWS credentials. So AWS has an SDK that you use when you want to interact with their cloud services. And to interact, obviously, you need to provide credentials, but has an interesting behavior, which if you don't provide credentials, it will fall back to a set of mechanisms to retrieve those credentials. And for example, for Golang, the order is the one in the slides. So yeah, so basically this is the behavior of the AWS SDK. By the way, if you want to know more about this bug or you don't understand from my 2 minutes explanation, there is a blog post out that was released this week, all the details, and you can also play with a demo that I will be showcasing right now. So imagine you have an app that has import from S3. It makes sense to have a code like this one, where if there is some error, you actually clean up the credentials, you try to get stuff out. However, because of the behavior I just explained, if you do that, the SDK will actually, and the implementation that you have on the server side will go back to the chain. And it will go, 1, 2, 3, 4, and 4 is actually the roles that you have on the machine. So if the machine that is provisioned has, a much higher privilege role, then you can leverage that. So let me do a check time. Yes. Let's see. Let's try to do a quick demo. All right. So this is the import from S3 thing. Let me take my notes so I don't mess with the. Let's use the same vulnerable VS Code to check stuff. So. Let's try to do the normal case. So the normal case of this application is you set your own bucket, you set your access key, you set your yes, and we will revoke those keys just after the talk. So if you want to run crypto miners and stuff, you have like 50 more minutes. So we set these things, we do the data import, internal network server error, fantastic. Let me see my connection. Exactly. Okay, of course, something had to break. Actually, it did work, I think. Yes, it did work because it actually loaded stuff. Now, what happens sometimes in web application is that a lot of the references that you have around, or for example, in the HTTP request, you will have references from the app itself. So if you look at, for example, where this image is hosted, well, sorry. Copy image address. You see that it's actually on this data internal private that is not reachable. So if you try to access actually this file, which I know it exists on this repo, it failed. But if we take the S3 bucket, we don't provide credentials so that we want to simulate that. And we import, we see that the data import correctly. And you can see now here that we can actually access the key. So this is a way to basically access internal S3 buckets, assuming obviously you can find credential in one of the items from the chain. Prototype pollution, I know it's very popular. It's been, discussed a bit already, but I think it's still underestimated as a, new class of vulnerabilities. What is prototype pollution? Just think about this example. That's all you need to know. You define an object in JavaScript with an attribute name. If you do a toString, you would get object, right? Because you are trying to do a toString on an object. But then you can override a toString by doing an alert. So if you repeat the same code, you haven't changed the code, it will behave differently. It will prompt an alert. Two of my folks, Norbert and Victor, found a regression bug in a very popular ORM library for JavaScript and TypeScript. This is what you would normally use to build secure SQL query and deal with databases. In this library, there is a part where it uses a deep object assign. It's basically a way to merge objects. Again, let's see code. Code is truth. So, so this is literally a copy of the code of the library, which is funny because it's a copy of Stack Overflow. Why not? And there is this merge deep function. It does a bunch of things, but basically it's combining objects. So the interesting things you want to know is line 39 and 40. You basically create an object A, which is an empty object. Then you create an object B using JSON parse. JSON parse takes JSON formats and creates a JavaScript object. You do merge deep, A and B, so that's the vulnerable function. And then if you do, basically if you create a new object and you check for that attribute is there. So again, very quickly, let's try to. So if we run this one, you see pawn true, right? We've been able to override. Now, what is interesting here is that this function was used, is used inside a function that is used when you save data inside a database. So let me actually first show you the code, and then we can try, and hopefully all the MySQL and stuff things that made me not sleep last night, it actually is working. First I need to find it. So, okay, so that's the SQLi. No, sorry, that's not the SQL. I mean, that's a SQLi, but it's JavaScript. We like TypeScript, right? So we want TypeScript. Okay, so the save function, line 9, is where it's using the deep merge. So the idea is that we create an object, we save that object using the vulnerable function. So because we saw how the function is implemented, how it behaves, it should pollute. And then we do a find query, line 13, where we're trying to find, in this case, all the categories of post, okay? So let me first run it without the pollution, and then we can do the pollution. So let's see, how do we do that? So yeah, let's do it this way. I will explain why it's in the try and catch stuff, but let's see first if it works. So here we're just executing the SQL file, and it's connecting to the database. We are just doing a find for all the all the categories. So we run this one, and we see that there are two categories: TypeScript and programming. Now, I don't touch, I'm not doing anything else. But, I'm just editing this thing. So what we do is we do the pollution. We save, right? The merge deep is inside the save function. And then because we are saving an object, it will trigger an error. It will fail. And so, it will actually terminate, but I want to show you everything. So I'm putting the stuff inside a catch error. In a normal scenario, what you would do is just do another request to the web server or just do another query. And so now we do the same find query, so the same select star from category, but this time we polluted with the where name equal programming, which is here. So let's see if it works, and if it works, then I can explain a bit more. No, so that didn't work, but because I didn't save, I think. Yeah, and you see here, it's only printing out the programming because we made the select statement. If we would change that one or we would do any other injection, that would work. And obviously, this is not something you would expect in a library that is supposed to build properly correct SQL queries. And it's an interesting thing where while SQL injection are dead in most modern application, you can still leverage interesting vulnerability like this one to then trigger traditional vulnerabilities such as SQL injection. And last bug, and hopefully then we go into the trends, is parsing. This is the code of a web application on the backend that attempts to validate URLs to prevent open redirect. Despite the name, which is this is the original name, but it's incorrect. It's not sanitizing. It's just validating. It basically checks if the URL that is provided after being parsed doesn't basically it's not HTTPS and it's not secureapp.com. It will return. And otherwise we'll return, we'll return like empty. Otherwise we'll return the actual URL. The URL is then used in a 302 redirect, which is then processed by the browser to do the redirection. But one parsing is done on the back end and one parsing is done on the front end, or in this case in the browser. And URL parse actually behaves differently because they're actually different implementation. So if you if you see the Node.js side and you try to parse this particular URL with its Unicode character, you see that it resolved to a host app.secureapp.com, which is an allowed host. But if you do the same on the browser, which is at the end what is actually doing the redirection, you see that it actually will redirect to a completely different host that contains a domain under the attacker controlled. So this is just an example, I think a sweet example of parsing. And parsing bugs are great, so you should go out and find parsing bugs. So let me go into conclusion, and if you do what we do, some tips and tricks. First of all, finally, we are no more second-class citizens. You can do cool stuff with web and not spending your day on IDA or other debuggers, which is amazing. There are a few trends and good things, good news and bad news in both sense. So I think we got to the point where we actually found a way to kill some bug classes. And unfortunately, it's not through education, as not that education is not important, but it's not really how we're killing class bugs, class of bugs. The way we do is through better standards, browsers, security mechanism, and other things that are implemented by tech companies to make more difficult to introduce bugs or mitigate those classes. So cross-site request forgery is dead because of same-site cookies and because of most of frameworks nowadays using authentication based through headers instead of cookies. Obviously, same-site cookie is a relatively new technology, but all browsers are implementing it, so it's going to die. Then traditional XSS is also dying because of React and Angular. If you have ever done any security audit on React apps, you basically have to grab for like 6 things, and once you've done that, there is no way to do XSS. Otherwise, you found a bug in React. So again, better frameworks are helping there. Injection bugs are getting rare for the same reason. So all in all, better frameworks and a lot more investment, particularly around browser vendors and tech companies. But don't worry, you can be a pen tester for the next 50 years. I will definitely retire by the time we solve all the problems. And there are a lot more new classes of vulnerabilities. And I think the most interesting things here is it's now time to find a lot more bugs in order to do more interesting attacks. So it's getting a bit more complicated, but honestly, there is also a lot more published online with all the bug bounty movement. So I think we're in a good state for job stability. Some tips for auditors. Don't immediately jump into testing. Like sometimes read the manual, which works on both sides, like defender and attackers. But really, you can find bugs before you even open your Burp Suite. There are a lot of new things out there. Like I can still learning after 20 years. And that's great. Like at the beginning, when I started, I was overwhelmed by the fact that I knew I had to learn so much. And now actually, the more I know I need to learn, the more I'm excited that I can never stop. Very interesting things is, which is a tip I usually give to my folks, is if you find a bug or you have, like you know there is a bug, look for the same bug in different places, or look for different bugs in the same file. And I will tell you a story, but in the next slide. Of course, look where there are complex things, where the system are interconnected, like the cloud and the web app, and where are basically parsing and mismatch-prone functionalities. So the complex stuff, this is where people make mistake. If you're a defender, there are a bunch of things you can do. They're listed here. The sparse and dense story here is, I attended a Facebook conference, which I guess the video is public. And one of the person that was responsible for the bug bounty was telling a story where they started receiving a lot of reports on certain files that affected certain files of the platform. And it turned out was the same intern pushing code to production that was, didn't know a lot of secure coding practices. And so basically created a lot of bugs around. So, and this is where the idea of, look for different bugs in the same file started, because if someone is implementing a functionality and it's, a one-man business, then there might be more bugs there. Or this person is working across multiple, features, then there might be bugs that are sparse. And of course, this happens for multiple reasons, but it's funny. I always think that it's an intern creating problems. But you should still do internship. They're great to learn. And with that, I don't know how much time we have. Oh, well, then perfect.